Welcome to ConcreteSection. In this video, we'll explore how the software calculates and displays the interaction surface and diagrams for reinforced concrete sections. Let's get started. Interaction surface fundamentals. The interaction surface represents the strength of a reinforced concrete section for every combination of axial force and bending moments, capturing how nonlinear material behavior and section geometry influences capacity. ConcreteSection computes this surface using strain compatibility, constitutive models for concrete and steel, and equilibrium, as discussed in detail in the Analysis Fundamentals training video. This mechanics-based approach provides a more detailed and accurate view of the section capacity than traditional hand calculation methods like the Whitney stress block. ConcreteSection is especially useful for calculating complex cases involving asymmetric shapes or biaxial bending problems where simplified methods often fall short. Interaction surface computation. To generate the interaction surface, ConcreteSection performs the following process. Given a specified concrete failure strain, either epsilon naught or epsilon u, which can be set in the program, along with the neutral axis offset and neutral axis angle, the software calculates a single capacity point defined by axial force, Pn, and biaxial moments, Mnx and Mny. By systematically varying the neutral axis offset and neutral axis angle, ConcreteSection computes a range of these capacity points, ultimately building the full interaction surface. You can control how refined the interaction surface is by adjusting two settings: interaction points and quadrant slices. Quadrant slices refer to the number of interaction diagram slices used in each quadrant of the surface. Each slice corresponds to a different neutral axis angle. For example, if the quadrant slices are set to the default of 20, the program generates a total of 80 slices through the interaction surface, which is 20 per quadrant for the 4 quadrants. Reducing the quadrant slices to 4 results in just 16 total slices, making the surface significantly less refined. Interaction points refers to the number of points used in each interaction diagram, where each diagram is a vertical slice through the interaction surface. Each point corresponds to a different neutral axis offset. If you examine the MX interaction diagram, which is a vertical slice through the origin, and turn on data points, you'll see 100 points on each side of the diagram by default. Going back to the model view and reducing the interaction points from 100 to 10 makes the diagram much coarser. Note, you can turn on flyby annotations to see the axial load, moment, and strain in the steel at each point you hover over. Switching over to the Surface tab, you can also see the visual effect of reducing the number of interaction points, resulting in a less detailed surface. The interaction points and quadrant slices can each be set as high as 2000, allowing ConcreteSection to generate a highly refined interaction surface when needed. In ConcreteSection, the software numerically integrates stresses over each triangular element in the mesh to compute the forces and bending moments for the interaction points. The mesh refinement setting controls how finely the section is discretized. Higher refinement improves accuracy of the interaction surface but increases computation time. As mentioned previously, the interaction points that define the surface are calculated at a specific concrete failure strain. This failure strain, which is the strain in the section's extreme fiber at full capacity, can be set to either epsilon naught, which is the strain at peak compressive stress, or epsilon u, which is the ultimate strain. This setting directly influences the section's calculated capacity and shifts the bounds of the interaction surface. Interaction diagram views. To help you visualize and evaluate the interaction surface, ConcreteSection offers several interaction diagram tabs. The MX tab displays a vertical slice through the surface where my equals 0, showing the PN versus MNX interaction diagram. The MY tab displays a vertical slice where MX equals 0, showing the PN versus MNY diagram. The Flexure tab shows a horizontal slice through the surface at PN equals 0, plotting MNX versus MNY. Note in the MX, MY, and Flexure diagrams, users can specify an offset that defines how far the interaction diagram plane is shifted from the origin. This makes it easy to view specific slices through the interaction surface. This is especially helpful when you need to visualize the capacity at a particular point in the section. The moment unity diagram becomes available only after loads have been applied to the section. For demonstration purposes, let's apply a dead load, and then let's apply a live load to the cross-section. In the Load Case Manager, we can then view the various load combinations generated from these applied loads. With the loads defined, the Moment Unity tab becomes active. This view shows horizontal slices through the interaction surface for each result case where the slice is taken at the level corresponding to the axial force for that case. You can change the result case to see these various slices. The factored loads in your project can be shown on the MX, MY, Flexure, and Surface tabs as points on the diagrams and surface. This helps you quickly determine whether your applied loads lie inside or outside the interaction surface. Interaction surface and diagram data. Finally, it's worth noting that all data for the interaction surface and diagrams can be viewed in table format in the report. This allows you to review specific values or export data to Excel if you'd like to perform additional calculations or create your own diagrams. Note when graphing numerical data, be sure to include the points column. This helps ensure that the points are plotted in the correct order. That wraps up our look at the interaction surface and diagrams in ConcreteSection. You've seen how the surface is generated, how to control its refinement, and how to navigate the different diagram views. For more details, check out the user's guide or explore our other training videos. Thanks for watching and have a great day.